is equal to the mean of the x is equal to, it's a new x here, and the mean of the expected value of y is equal to, so it's a new y here. That's what we are having here. And you have taken already, you have taken the mean of u, you have taken here. So the mean of u is equal to, so it's a new u, which will be equal to the, so new x into a plus new x into new y into b, you are taken here. So similarly, the mean of v is equal to the, so new x into c plus new y into d, you are taken here. Already you are taken that one. Okay. So now we are going to find out the variance of the u. We are going to find out here the variance of the u here. Okay. So I think you are taken. Take, if you are not taken, the variance of u is given by the variance of the random variable u, it is given by, so the variance is nothing but, so you know that the variance is nothing but sigma u square. So this is nothing but expectation of the difference between the random variable u and its mean new u, you're going to call here. You're going to call. So in the last class, I guess we are done up to this point here. So video clarity is there, I guess. Okay, it's there, no? It is there. Okay. So yeah, so it is it okay, right? Okay, so
Yes,
new
sir.
u square is equal to expected of the u minus new u the whole square, you're going to call. Substitute for the u is nothing but, so ax plus by. So u is nothing but ax plus by here. Okay, so and v is equal to the new u is equal to the new x into a plus new y into b here. So let us substitute that one. Okay, so I think in the last class we have substituted that also. So that is u minus new u. Okay, so sorry, in place of u we can substitute as a into x plus by minus new u is nothing but, so new x into a plus new y into b, we are going to substitute here. So let us take the multiply the product minus with all the terms here. Multiply the minus with all the terms here. So we are done that one, I guess, in the last class. Ax plus by minus a into new x minus b into new y. We are done. Okay, ax plus by minus a into new x plus minus b into new y. We are done that one. Okay,
The
as
square
b.
root.
Okay, so
Whole
on the
square.
square is there. Yeah, square is there. Square is there. So let us take that one. Let us separate the a terms here. So it is a into x minus new x. Let us take here plus b into y minus new y. Okay, so the entire thing square is there. That is nothing but sigma u square. The entire thing square is there. Okay, so sigma u square is equal to expected of a into x minus new x plus b into y minus new y, the whole square. So that is the square is there for that one. Now let us apply the formula for the a square plus a plus b the whole square here. So a square plus b square plus 2ab will get here. So I'm going to apply that formula and let us expand that one. So the first term is a into x minus new x, the whole square will become, so a square into x minus new x, the whole square. Okay, plus b square into y minus new y, the whole square, plus 2ab will get here. So 2a into b into x minus new x. Okay, so into y minus new y you will get here. Y minus new y. X minus new x into y minus new y you will get here. Okay, so y minus new y will get here. Y minus new y. Applied, no? So we applied the a plus b the whole square formula. So we got this one, we got here. Now I'm going to evaluate the expectation for the individual terms. I'm going to evaluate here. Expectation for this term, expectation of the constant is a square is the constant, b square is the constant, and 2ab is the constant here. I'm going to evaluate the expectation for the individual terms here. So let us see what we'll get here. Okay. So you have taken these terms. So I'm going to evaluate the expectation here. Okay, if I'm going to evaluate, so it has become, so sigma u square is equal to a square into the expectation of the first term, that is x minus new x the whole square, plus the second term, so it is a b square. The expectation of that one is okay. So x minus the expectation of that one is, so y minus mu y the whole square, so plus the last term is nothing but, so it is a 2ab is the constant I'm going to take outside here, so it's the expectation of x minus mu x, okay, into y minus mu y will get here, y minus mu y. Okay, so I'm going to evaluate the terms for the individual terms. I'm going to evaluate here expectation for the individual terms. Okay, done. Now we have seen from the single first module, the expectation of the x minus mu x square is nothing but it's a variance of the x here. So we can write sigma u square is, so it is a square into the expectation of this is nothing but sigma x square. I'm going to write here sigma x square. The expectation is sigma x square here, and y minus mu y the whole square is nothing but it's a the variance of the random variable y. So it is sigma y square plus the expectation of x minus mu x into y minus mu y. Already we have seen in the last classes. So that is the thing, but it's a covariance of the, we have seen that one here. The expectation of x minus mu x into y minus mu y. So this is the thing, but it's a covariance of the x comma y here. Covariance of the x comma y. So I'm going to write that one as a, so 2ab into, so covariance of x comma y, the covariance should be written in the square bracket like this here. So covariance of the x comma y, we are going to write like this here. That, so this is a variance of the random variable u, which is a transformed random variable obtained from the x and y. We are going to get like this here. So done. Okay. So similarly, we are going to do it for the sigma u square here. We can take similarly. So we have v is equal to the, so it is a c into x plus d into y is a c into x plus d into y. So let us do for that one. So the sigma v square, so that is the variance of the random variable v is given by, so sigma v square. So this will become equal to the, so in place of a we have c is there, so it has become c square into sigma x square plus in place of b we have d is there, so d square into sigma y square plus 2cd into, so covariance, so this is covariance, so covariance of x y will get here, covariance of x y will get here. So done. Done. Okay, now it's visible. Okay, video clarity is there.
Sir.
Yeah. Okay. So far we calculate the. Okay, fine. So done. So we are done with the covariance of the two random variables we have seen here. So now let us find out the. Now let us find out the other factor which is called as the covariance. Let us find out here. Okay. So now let us find out the covariance of the random variable u and v. Let us find out that covariance here. Okay. So the covariance of u and y, you can take the covariance of the random variable u and y, u and v. We can take the covariance of the random variable. The covariance of the random variable. Can you hear me? The covariance of the random variable.
Yes,
yeah. So you can take the covariance of random variable u and v is given by the covariance of the random variable u and v is given by. So you're going to find out the covariance of the random variable u and v here. So covariance is nothing but, okay, the covariance is nothing but it's a covariance of x comma y is there. So similarly we need to find out the covariance of u comma v is equal to the expectation of u minus the mean of that one, and v minus the mean of the v here. Okay, so let us find out that one here. So I'm going to write the formula, the covariance of u v. So this is equal to the expectation of the u minus nu into u. Okay, so v minus nu into v will get here. So the covariance of u and v is equal to the covariance of u and v is equal to the, so expectation of u minus the mean of that one, v minus the mean of that one here, we are going to write here. Okay. Now we know that the u is nothing but it's from the combination of two random variables xa plus by, and v is nothing but cx plus dy, and the mean of u is nothing but so nu xa plus nu yb, and mean is nothing but this one here. Let us substitute these things in this expectation here. Okay, so I'm going to substitute the same thing here. So covariance of u v is equal to the, so expectation of u, so u is nothing but it's ax plus by minus by minus the mean of that one is nothing but so a into nu x minus, I'm going to multiply minus here, so minus b into nu y. Okay, so that is the I'm substituting for the term u, and nu v I'm substituting here. So similarly, let us substitute for the term v and nu v here. So I'm going to write here, so the space is not sufficient here. So v is nothing but it is cx plus dy minus the mean of that one is so c into nu c into nu x minus d into nu y will get like this here. Okay, so right, so expectation of ax plus by, that is u is nothing but this one, so nu u is nothing but this one, so v is nothing but this one, nu v is nothing but this one here. So let us segregate the terms, a terms and b terms, let us segregate here. So I'm going to segregate here, so that is the expectation of a, if I'm going to take common here, so it is a into x minus nu x. Okay, so a into x minus nu x plus, okay, so b into y minus nu y, y minus nu y. Okay, so this is the one group, and the remaining term, let us segregate the terms like this here. So c into x minus nu x. Okay, so plus d into y minus nu y. So this is another group here. This is another group, and this is one group we have here. So right. So we have a into x minus nu x plus b into y minus nu y. So this is one group here, and c into x minus nu x plus d into y minus nu y. So this is other group here. Okay, so here we have this one expectation of this is called something x, and this is called something y here. Okay, so since the random variable c and u and v are not independent random variables, so if it is an independent random variable, we could have written this one as the expectation of this into expectation of this, we can write here. But since the random variable u and v, since the random variable u and v are not the independent random variables, so u and v are not the independent random variables, so we can't write like this here. Now what shall we do is, let us take the product of this one. So assume this is a plus b, this is c plus d here. So a into this one plus a into this one plus b into this c plus b into d. Let us take that one and let us write the product. Let us write here. Okay, now we'll do the product. Let us take the product of these terms here. Okay, so I'm not going to expand, just I'm going to multiply the terms here, and let us see what we'll get here. Okay, so we have the covariance of QV. So this is a thing, but this is a thing, but okay, so this into this will become, so a into c, it will become ac. So x minus nu x, here also x minus nu x, it will become x minus nu x d whole square, x minus nu x the whole square plus, okay, so this into this, so it will become a into d x minus nu x, x minus nu x, next y minus nu y, y minus nu y. So this into this we got here. Next multiply these terms here. So b into c, sorry, b into c. So b into c, y minus nu y, and x minus nu x. Okay, next to b plus b into d y minus nu y the whole square will get here. Y minus nu y the whole square will get here. Okay. So right, y minus nu y the whole square, when you take the product, so we'll get like this here. X minus nu x the whole square plus AD x minus nu x into y minus nu y plus BC into y minus nu y, this one here. Now let us evaluate the expectation for the individual terms here. Evaluate the expectation for the individual terms. So this has become A into C is the constant. The expectation of the constant is constant only. So it is x minus nu x the whole square plus A into D, the expectation of the x minus nu x. Okay, so y minus nu y. Okay, so plus B into C, expectation of the. So I think we can write this one as the. Okay, so here also x minus nu x, y minus nu y is there, y minus nu x. Okay, both x minus same here. So let us write later. Already we are written. Let us group together. Let us take these terms common. You can take here, and this will become AD plus BC will get here. AD plus BC will get. Okay, so plus B into D into expectation of the y minus nu y the whole square will get here. Y minus nu y the whole square. Okay, y minus nu y the whole square will get here. Okay, done. Now you know that the expectation of the x minus nu x the whole square is nothing but it's a variance of the random variable x here. So we can write A into C into sigma x square. We can write here A into C into sigma x square plus. So these two terms are common. We can take here. So this is nothing but x minus nu x, y minus nu y is nothing but it's a covariance of the random variable x and y. Covariance of the random variable x and y here. So this is product of these two terms are common here. So we can write AD plus BC. We can write AD plus BC plus BD into, this is called as a variance of the random variable y, sigma y square we are going to write here. So this is the covariance of the random variable u into v here. Covariance of the random variable u into v, we are going to write like this here. Done. So this is the covariance, this is the covariance. So if I take the common here, so it is AD plus BC we will get here. AD plus BC. Done. So this is BD, B into D into sigma y square. Done. Okay. So right. So this is the how we got the covariance of the transformed random variable. We can obtain here the covariance of the transformed random variable. Now what you are going to do? So in the textbook it has been given. So they're going to transform the whatever this random variable x and y. They transform in terms of the u and v here. Okay. So now we can take here. We have so done. Any doubts till this point? Any doubts till this point? Okay, it's audible, right?
No, sir.
Yeah.
Yes.
Okay, fine. So you can take. So already we have something called u is equal to the ax plus by. We can take. We have. Okay, so this is up to one part. This is next. We are going to take it as a. We are going to express the x and a and b in terms of the cos and sine. We are going to express here. So we have u is equal to ax plus by and v is equal to cx plus dy here. Cx d plus dy. Now we need to express the x and y in terms of the u and v. We need to express here. So as an inverse transform, we need to express here. So this is called as a forward transform. That is, we are going to express the two random variables x and y. We are going to express the two random variables x and y. Okay, in terms of the two random variables x and y in terms of the u and v, we express it here. Now let us perform the inverse transformation. Inverse transformation is nothing but we need to express the x and y in terms of the uv and the remaining quantity here. Okay, so uv and the remaining quantity. So let us do that one. So what I'm going to do, the here y is there. So from this one, here y is there. So from this one, I'm going to express the dy is there. So it will be taken. So it will be equal to the v minus cx will be taken. Ry is equal to the, so v minus cx. So first I'll solve it here. Later I will do the substitution for that one here. Okay. So y is equal to v minus cx divided by d. V minus cx divided by t. We are going to substitute here. Okay, you can see now. So we have u is equal to ax plus by, and v is equal to cx plus dy is there. V is equal to cx plus dy. From this one, I am solving for the y here. So y is nothing but v minus cx divided by d will get here. V minus cx divided by d. Okay, so done, right? You got it right? Okay. Yeah. So now let us substitute this y in the expression for the u here, and simplify for the x here. Segregate only the ax here. So ax plus b into, so y is nothing but, so v minus cx divided by d. Okay, let us take the LCM and segregate the x terms here. If you take the LCM, so u is become a d, sorry, ad into x plus okay, so b into v minus, if I multiply here, so it is become bc into x will get here, bc into x. Okay, so now cross multiply the terms here. So what I am doing is I am substituting the value of the y in the expression number 1. If I substitute here, it has become, I'm substituting the value of y in the expression of the u here. Okay, expression of the u here. So you're going to get like this. So ax plus b into this one. So let us take the LCM. Take the LCM and segregate the x terms here. So if you're going to segregate the x terms, so segregate the x terms here. So if I segregate here, it will become, so I'll write in the next page. So u into d is equal to, so x if I take here, so ad minus bc, ad minus bc into x. Okay, so plus b into v will get here, plus b into v. Okay, so let us separate the x terms here. So if I separate here, so x will become, so ad minus bc is equal to ud plus bv, ud plus bv, so divided by, okay, so we'll get here, so x is nothing but ud plus bv divided by ad minus bc will get here, ad minus bc. Okay, done. Similarly, let us okay, so let us write the expression for the y here. Similarly, let us write the expression for the y. Okay, so still okay, the same network issue is repeating. So my voice is audible, right?
Yes, sir.
Okay, fine. So similar way, find the expression for the y here. Similar way, find the expression for the y. So in that one, let us substitute. Okay, so what we can do is, okay, similarly, let us find out the expression for the y. We can find out here. So do that as a homework here. And in that one, what you are going to do is, you are going to substitute u is equal to the ax plus by is there, no? Ax plus by is it. So in place of a, we are going to substitute a is equal to the cos theta. We are going to substitute here cos theta x plus, in place of the v, we are going to substitute the, in place of the b, we are going to substitute the minus sin theta. We are going to substitute here. Okay, so in place of the b, we are going to substitute the minus sin theta. So a is equal to cos theta, b is equal to minus sin theta. We are going to substitute here. So similarly, in place of c, we are going to have sin theta. Okay, sin theta x plus cos theta y. So what we are going to do, we are going to substitute c is equal to the sin theta and d is equal to the cos theta. We are going to substitute here. Okay, so in this transformed random variable, in this transformed random variable, that is ud plus bv, what you can do is substitute the d is equal to the cos theta, b is equal to the sin theta. How you are going to substitute, you can see here. So these are the substitutions you are going to do it here. Okay, so u is equal to ax plus by. A I am going to substitute as a cos theta, b is equal to minus sin theta. I am substituting here, and c is equal to sin theta and d is equal to cos theta. So if you are going to do substitute, we'll get the value for the x and y we are going